Okay. So it has been, I think, I don't know, at least 10 years since we started to do these MFC workshops. And the technology, some of you might know, some of you might not know, the technology, it's called microbial fuel cell. If you Google it, so there are, I would say, quite a few institutes, scientific institutes, who do research on this technology at the moment, and in past years also. When we started, it wasn't very developed yet at that time. So actually, it's pretty simple, but still you need some parts like materials for electrodes, and those were not industrially produced at the time we started. So we had to come up with our own solutions. Today you can buy pretty much everything what's needed for this technology online, and can build different kinds of fuel cells. But how we arrived to this actually was we had another idea for our art project back like in 2010 or something. We wanted to power it from the nature, like not using the solar cells or wind turbines, but actually to power it somehow from the earth. And we came across with because with the help of our friends, biologists, we came across with this technology. So after a few experiments, we realized it doesn't power anything much. So you can power something, very little, but not the needs we had. And but then we decided, okay, so it's interesting on its own. And the first project we did was a sonification project. So we actually used the movement of the electrical current to create a sound. And then later we moved with this project further, and we also used the video image, which was also manipulated with the fluctuations of those numbers. So gradually we ended up with actually practical use of this, and we were invited for the museum in Berlin, Futurium, in 2019 to do an installation there, and we built a small installation with these microbial fuel cells, I think 5 of them, if I remember correctly, and we managed to power an electronic clock. So it was supposed to run for a certain time, and then the museum actually, it's in a permanent exposition there, so they said they will take care of it along the time. So because you have to change the mud, so with the bacteria from time to time, like we've been testing in our lab in RIXC also to have the similar module running the same clock. So it works for about a year, and then you actually can boost those cells for a while. So then it works maybe for a couple months, and then you can boost them again a little bit. So by boosting, I mean I will show you, you change the water part and you add some water, so you do a little maintenance, but not adding anything. So, and once the bacteria, I don't know, eventually has died there, or they are not active anymore, so so you have to change the whole environment, the whole dirt. So that's pretty much about it. And then, yeah, we built those kits for doing workshops, like one we will have today. And there will be, hopefully we'll manage to do 3 types of bacteria cells. So one would be a 2-chamber cell, another will be 1-chamber cell, and hopefully we can manage one cell to plant in our pond over there in open air. So that's, I think, the most fun. So you can come here, and I will make maybe a drawing of what we will have to build. So for this would be for a 2-chamber cell, you actually need to have two containers, and this is the water side, and this is mud side or dirt. And then you have to connect them with, industrially they connected with the membrane. There are these industrially produced protein membranes which kind of separates those two parts, but they allow to travel free protons and electrons from one chamber to another, obviously from this one to that one. And then you need two electrodes. We don't have this industrial membrane here, so we will use, where do I have it? Just a plastic tube. But this has a thread, so it's made to be convenient, so that you can mantle and dismantle. But this tube we will fill with agar jelly. And the agar jelly pretty much does the job, at least for a short period of time. It does not last very long, but it can go for a month maybe or so. It does the same job as the proton membrane. So basically it interconnects those two chambers, and here we have this agar jelly. So we will have to make a jelly. And then we have electrodes here, one electrode and another, and those in the beginning, when I said we had to make our own, so in this side you need a carbon, because bacteria tend to inhabit on those carbon materials which you have here. But to collect electricity or flow of electrons, actually you need conductive carbon, which is now produced in variety of ways, ranges. So this is conductive carbon, this is conductive carbon felt, then you have a conductive carbon cloth and all kinds of stuff. At that time, there was no accessible this kind of carbon, so we produced it ourselves by just burning cotton cloth. You can do it like when you have a closed container, put the cotton cloth inside, and then place the container in high temperature, like in a fire, for instance, like campfire. Yeah, that's how we did it. Make a small hole, then when it burns, so just the CO2 comes out very quickly, and then you get pretty fragile, but still you can use it. It's not conductive, so therefore we used stainless steel mesh, this kind of, and we folded it inside that stainless steel mesh, so this carbon. I don't have any examples because they don't last, so eventually they got destroyed. And that's on this side, and on the other side you can have any conductive material, so we used stainless steel mesh. Now we can use also these electrodes, which are conductive carbon. These are plates which probably are not the best for this kind of construction, because they don't have, they are not as how do you say, there's not as many air gaps as in a felt, for instance. Because in this, the bacteria go inside, and you can make a large colony of bacteria. So here they sit on the surface, and you never know how many there will be. So, and the whole thing works because bacteria, they consume organic matters which are here in the dirt, and through that process, so free electrons get released from the organic stuff on like microbial level. And in nature, it just works that those electrons travel towards the oxygen, and they kind of get kept by oxygen molecules, and that's all. Here that's why we need anaerobic environment in this mud container, because if there is an oxygen, so then the part of electrons will not be captured with our electrical chain, but they will just go in the air. So this is one thing we're gonna build, and then the other one, which will be using these felt materials. So it's a one-chamber cell, and you just need one container for that, and there you put one electrode on the bottom of it, and then you fill it with mud. Maybe depends how large the container is. Like if we use these ones, so I would fill it maybe halfway or a bit more than halfway. So you need some distance between this electrode and the top electrode, and then the other one goes on the top. Which one we will use? This one. It's a bit thicker because it has to be partially submerged in a top layer of mud, which is also a little bit of water here. And then there are just two wires attached to those, and you can put a lid, but it's not kind of really necessary, so it works also without a lid. So that's the other. And this principle also we used in the pond. So actually you can experiment with the depth of the particular pond. And here we have sediment of the pond, and we place one electrode here. We wire it up, and then another we just keep floating on the surface, and then we wire it. And then, yeah, we haven't kind of done any scientific observations or tests. So just from experience, so it works starting maybe from 40 centimeters up to 1.5 meters, which we've tried. So I'm not sure, maybe it works also in deeper situations. So
you've tried it in this pond?
We've tried it in this pond. We've tried it in a Riga Botanical Garden where we had an installation. And their pond is about 1.5 meters deep. And we tried it in Netherlands, also in Eindhoven. So there's a Van Abbe Museum, which has a river going along the museum. And there's a nice pocket at the museum. So the river makes kind of nice pocket. And that's really very good place for this kind of technology, because the sediments are very rich there. And I think the depth was about maybe also 1.5 or 170 or something, pretty similar. So we don't do much science with this. We just do kind of hands-on thing, and sometimes it works instantly. Sometimes it takes, like, more. If it's properly made, it will work eventually. Maybe it will work tomorrow. Maybe it will work instantly. So it depends really on the mud, and it depends also, like in this case, on those agar bridges, so how good they are.
Is it better if the mud is fresh? Like
yes, of course, yeah. This is not very fresh, so we'll see how it will work. But as less, for instance, so as more organic matter is there, as better. So usually if you just dig from the ground, so there's lots of sand, and that does not help. So I will show, you can decide who is making which kind of a cell. For these two-chamber things, there are also gloves you can use. For these two-chamber cells, it's a bit longer process because we will have to cook this agar and make a jelly. And then we will have to wait until it hardens. So, batteries, so we don't need. So I'll just show you how to prepare these things for, and these knots actually are they're different threads. So if you take one, so please keep your knots with you because they don't fit to all. So this is for this one, yeah. So you just use a small piece of foil. There's more there. And we need to close one end of that plastic tube. because the jelly will be poured into this one, and we need it to stay. So you can prepare these things like this, and then I think I will go, or you can make a jelly. Okay, so you can go inside and make a jelly. Not much, so just how much we need, like 3 tablespoons. So just pour water, maybe this much, like really.
Was maar afweten now?
No.
The foil is for, well...
Foil is just for closing one end of the tube, so you can close it with anything else as well. So it's just
Conductive.
No, it will go away. So it's just for yeah.
Right.
One each? Or
Yeah, one each. So you take one each. So then those who want to make one chamber cell, I will show. I have some.
Okay, what can go wrong?
So we use these ones, right?
Those gaskets you just leave them on because we will need them. So once you place these tubes here inside with the container, you attach them. So you need a gasket not to have a leakage.
So this one completely naked is not.
So you have to find gaskets somewhere.
Like this,
Yeah.
Ah,
Yeah, there are more here. Okay, and
Long enough, or is it too short?
it's fine. Yeah. Now for these ones. So these you can make right away without waiting for agar. Would be good to use, not to mix up the wires. So you need one red or orange in this case and one green, because one will be positive, another will be negative. And if we make them the same color, so we will not understand if the cell is working or not. Now we take one thinner felt electrode and one thicker, and green wire goes. I have these small hooks for them not to come out easily, so otherwise they just kind of come out easily. You just push in carefully the naked end of the wire, and these are industrially made again, so this comes from the kits which you can buy online, because the wires are important. So these are titanium wires, so they do not oxidize. If you use copper or iron wires, like metal wires, so after a while copper wires actually dissolve in a couple of weeks, so they just break because of current going through and because of environment. So, and also just the metal wires, so they just oxidize and yeah. So prepare those two electrodes like this, and these are not very fresh electrodes, so we'll see how they will work. So because they've been used. Yeah, the thicker one is for the red wire, so it will be on the top, because it has to be some, as I said, partially submerged. And then take, I don't know, either, like I have 4 containers. There's one here and there are like 2 of those single containers. So you can use them and just dig some mud. Let's see what we have here. Oh.
What is this?
Oh,
but these
let's.
ones have holes in them.
Oh, okay. So I will bring another one. So this will not work. So yeah, you can use the small one. No, this one. So put a little bit mud in the beginning, that you have just very thin layer on the bottom, and then place this bottom electrode and push it really that.
Is this okay? Or this one side is always.
Yeah, it was just, I just made it longer, so these titanium wires were kind of at a certain length, and I needed them longer, so that's why I extended it. It was just with a copper wire, so, but that, because the copper wire wasn't submerged in the cell, so it worked. No, we realized there are holes in there. And I will find another containers, like two another containers which we can use.
Is it difficult to get the titanium wire, or you order
Is this okay?
the titanium?
I ordered, yeah, so sure, yeah. These are, you can buy them online.
Thing is because you try to like create
I
an
tried,
airtight.
yeah. I tried to get rid of air bubbles as much as possible. Because again, so air is what captures those electrons and what makes our cell not working.
Ooh.
So, let's see how much mud we have. Hopefully we can.
Och sen 40 på.
What's the best mud
Men
that
det sa vi
you've
också
used?
på vinter och.
It comes usually from some sediments in a ponds which have been there for a while, so like for a longer period of time. I mean, like for maybe like hundreds of years even. So yeah,
I talked with
if you just make a pond now, so it will.
yeah, I talked
No.
to our mechatronics professor in university, and he said, yeah, there's like specific bacteria. I don't remember again the
Yeah, I also don't know
Yeah,
bacteria
the
names, so
names, yeah.
sometimes people ask me, I have no idea.
that makes it work. He said not always you will get lucky because there's
Yeah.
specific bacteria that's
Does it depend on like the pH
Yeah,
of
we did the
the
workshop.
pond or something? Like have you?
I had a 5-minute chat with him.
Oh,
but,
okay.
but,
No.
yeah.
I think it depends on many things there. Yeah.
Have you measured the parameters?
No, as I said, so
He also encouraged us.
we are more like a.
He wants to collaborate with artists. He wanted to make these paintable also batteries to this titanium cloth.
Ah, okay.
With the man, no, not with the man, but with the charcoal.
Oh, that's cool. Oh, what university is that?
Pepa University.
That's cool.
Yes.
So then, yeah, just fill it almost like, I would say two-thirds, yeah. Also have some water. Yeah.
With the
Not for this. No.
not for that.
Those are two chambers. So
Yeah.
for not for this
but I can
model.
later.
I will bring you. So I just finish this cell, and then you just submerge this top electrode and leave the top part open to the air. So, and can put the wires through the holes here, those who have these containers, and we just leave them for a while and see. They should start working after, I think, half an hour, or if we're lucky, maybe after 10 minutes. But I'll be back with I'll try to find better containers without holes for this. Gatavs? Ko? Nu tad ej, tagad turpini, jo man vajag jā, būs labi, man vajag burciņas priekš vien čambers šūnām.
Yes, it's stable, but yeah, actually.
Also depending on temperature and everything, it again probably fluctuates.
Yeah,
So good.
over time,
We have this type of containers, so I can make holes for it. So those who want to make one chamber cell, so you can use this one.
Why you don't have gloves?
Is it important?
There are gloves. No, it's not. I mean, it depends.
If you like bacteria, these are really bacteria.
Good for the guts.
Yeah.
You can wash your hands with the soap, and that's fine.
But gloves is much better.
Some gloves that actually fit me. Usually they're all
Okay, so here is a container ready for one chamber cell. Oh, no, I don't know.
Three.
Here is one more.
Can I take the container?
Yes, you can. I prepared another. Not today, really. Here's your lid.
Ah, thanks.
I made the holes for wires.
Great, thanks.
Esam izņemta arī šeit, jo tur bija tas ātris. Mēs jau varam savādāk viņu jāiels ārā.
Nu, nekas, jā.
Agar is like a fruit?
Is seaweed.
Ah, seaweed.
It's the same you put
Thick is, oh. I don't know, maybe also. Which one should be, which positive is thin or thick?
Positive is thicker, which is on the top.
Did it the other way.
Okay.
So the thinner goes on the bottom.
Yeah, okay.
Yeah, thinner green.
Okay.
Here is another.
Yeah.
Minus.
Sorry, why you just changed it?
Who wants?
Yeah, thanks.
And there's one more, yeah? Do we have electrodes for one more?
Actually, we didn't do. We did only the one chamber.
I didn't do that, so we can combine.
Okay, let's do it. Yes.
So 4, yeah?
You have a container?
No.
Okay, that's your lid.
And thin on the bottom, yeah?
Yeah.
We're missing a container.
One?
We're missing a container. Oh, so first I put that.
Oh, there's one more. So that's all I think. So that's all we have. You have to share, I think, because we don't have.
Oh, okay. Sorry.
There are no wires anymore. I think, yeah.
I took them, but
No. It's fine. So there's how many? You have one set. You have another set, and there's a third one. So that's all we have. Yeah.
so first, and then the month. And then this goes.
Okay. We can check already. So to see if anything is happening there.
Creation? No.
Oh, this one doesn't want to go inside.
Mm-hmm.
Twist it.
Plug in.
Now this will need some.
Like the half of
Mine is producing already something, which is 0.1.
half of power.
This one is negative, so this means it has to wait until it flips.
Then you need many of them.
It is not even 0 yet, so it's zero minus. So, but this is like proper, so this works now.
Oh, wow.
But
They're already working.
0,1 volts, jā.
Okay.
battery.
Tas kaut ko varētu.
Nu, viņš parasti, ja ir viss labi uztaisīts, ja labi dubļi ir, tad ir pat līdz 0,9 var dabūt. Bet, nu, viņš nokrīt, tā jauda nokrīt tik līdz tu pieslēdz patērētāju kaut kādu. Bet tā Nu,
Nu, ja saslēdz tādā virknē.
nu, ja virknē saslēdz, tad kaut kas strādā uz kaut kādu laiku, jā.
What's he doing?
It doesn't close completely. I just saw it in my permaculture, so now I really
Ko tu dari? Nē, nevajag neko.
Like this, more?
More, a little bit more, so because we need a distance between the electrodes. So this is larger container, so that's why you need a bit more. And also you need pardon?
More?
A bit more. I would add another centimeter. So and then on the top of it, I would add a bit more liquid mud or just
Water.
just water, just very little. So because I would put it like, yeah, put the mud and then I would put the top layer with the water, so like this.
Okay, but we are still missing the upper part.
It should work now. No, it's fine now, I think. So you can add the water. So you add the mud and then add a little bit of water.
This
So
one needs to be submerged or not?
yeah, partially. You just maybe you can kind of with the spoon you can steer it. No, not push it. Steer it a little bit. So I'll take a spoon that it's more even. So that's.
My lid.
But these should. Okay, so these are stiffening. Usually I put them in the fridge, but.
It doesn't matter.
That was important for that first one.
Ah, I see. Okay, so I can release my hands.
So.
It just doesn't close completely.
No, but that's not a big deal. So that the main thing is that maybe it also needs a little bit of water. So no, I would say maybe I'll steal some water from this one. There's a lot.
Oh, water.
It's too much here, I think. I just poured it too much.
Some river you can like economic a bit.
Should be okay now. You just leave it, put it and
Is there like some kind of swamps in
yeah, just fully kind of push it here. So and that's all. Yeah, I think it should be fine. But I need a bit more water to this one.
Even more.
Yeah, where was that? Oh, actually, I had it in here. Where did I have it? Oh, it's too much, but
The Volkswagen has a battery that's placed in such a way that you can get to one terminal. The other terminal is in where the bonnet does this.
Okay.
You can't get there.
okay.
All right,
So
thanks.
It's like a very egoistic.
So
Yeah.
now it should be okay.
Interesting.
Yeah. So we need to get another car.
Fingers crossed.
This is sweet.
Let's wait a little bit, like 5 minutes, and we'll see if this does something. So you finished, yeah?
Yeah.
Good. So now we can go in a 2-chamber version. So take one of those containers. So how many agar bridges we have? 3. So you have 1. There's 1 here
And 4.
and 4.
Yeah.
So I guess these knots were for this one. So basically find your knots, and I think it has stiffened. So just try if it's stiff enough. So and take off this foil that goes
Wait, can we eat it?
to the recycle bin.
Yeah.
What?
Don't eat.
Agar, yeah, that's edible. I mean, yeah, yeah. I actually, where is Rasa? I forgot to tell her. Maybe she didn't. Usually, you add some pinch of salt also here because it's more conductive, so it helps for exchange of protons. But I don't know if Rasa did it, so we just have to work with what we have. And then you just place a gasket on the outside and not on the inside, and you just tie the knot. And again, this is just made to be dismountable, so you can do it with just a regular plastic hose and connect it and somehow seal it with, I don't know, with hot glue or whatever, with
some plastic?
yeah, whatever seals it. Now we start immediately with the mud, and we put, and this will be mud consuming because it's larger. Hopefully we'll have enough mud.
Can we add more water now into the mud? Or?
Yeah, we can, but it will not work very well. So because eventually mud will settle on the bottom, and then on the top you will have just clear water. So it's good if you have mud at least that it covers this plastic tube.
Okay, yeah.
And then you can add water and mix it to have it a bit more liquid.
Okay.
There's one more.
I had a, somewhere I had. So then you steer it, because I just need more even substance.
This like
Food workshop, yeah.
experiment with.
You need some skills in
The color glasses, you see it as nice lasagna dish.
Just on the top question, this one, like this one, this goes.
that goes away. You need that.
This was just for.
Yeah, you take it off. Yeah. So then mix it, and then find a lid. On this side you need a lid which has, I mean, if there is no, we can close it, but there are like several holes there. So find one with the hole which is closed, then find a tube. I think this is the right one. This construction is kind of not sort of obligatory, so, but it's made in a way that you will eventually put this lid on the top of this, so there will go electrode, and this tube is just for some extra air to come out, so if there is some bubbling process happening, but usually it does not, so I mean it's not very needed really, so, but this is our scientist friends who actually designed it, so, but from practice I've noticed that it's not really needed, so it's just...
It's supposed to be more efficient, I guess, for the...
So, and then on the mud part goes one of these electrodes with the conductive carbon. And again, you unscrew it and leave the gasket there. And fix it like this. And that's it. Just I will steer it again. And then I would close it, and I will go to find some tape to kind of seal it properly. This will start working, I think, not right away maybe, but a bit later. So, and I need another container, which I would then place it on this side. And companions. And here we just put the clear water, so we'll go for the water. Oh, there's a hose here. And then you just pour clear water on the other side until it covers that plastic tube.
Yes. Yeah.
And then for the other side we can use these electrodes. So
Does it have to be closed hermetically or not?
the water side, no.
This container, no.
That has to be closed hermetically, yes. You should have steered that mud, so maybe there is some, I don't know, probably, but you haven't tightened this, so this is also not hermetic, so that is not hermetic. And probably there's a stone or anything, so something on the bottom there, so which doesn't allow you to push this. So you have to kind of find it with the...
The third hole you have to close, right? Too much or?
No, it's fine, so
water?
just add water, yeah, add water.
Because this one is not.
Yeah, you will have to close it with the tape or anything, so I will bring that tape, so that is something, with that lid, something, you can use that lid, so there is no, see there's a lid with the pipe attached weirdly to the, like, no, the other one. So on a table there's a lid with closed hole, so you can use that lid.
It's me.
Ah, okay, but that pipe is not correct, so you use the longer tube, yeah.
Okay, change. You need a...
Want to close this.
Okay.
But then I'll bring you a tape and you will close it with the tape, so don't worry about that.
Yeah, no, I thought we were building one, but we are building.
Okay, mine is ready, so I'll just put this hose inside the water so that the air doesn't go in there, so in the case any bubbling happens, so it just can go in there. I will bring the tape.
We have to keep the white.
Yeah, Roger has its own kind of battery workshop at the moment.
Yeah, this is funny.
Okay, so here you have it.
Should I put something inside first? Or
No, just close it with the tape, so you don't need that hole.
this side? You put
So we can also
Do you have some electricity?
use tape to seal it, the mud part.
Yeah.
Oh, that's not the mud part.
You mean like this, no?
Yeah. Yeah.
So if you want to seal it with the tape around the lid, yeah,
Okay.
that it's just needs a bit careful. How to say? Now we have this one. Where is my voltmeter? I don't see. Ah, so this. Let's check if this is working. Oh, that's a lot. So let's see how this is doing. Oh, see, it's rising. it was in minus, and now it goes up a little bit. So 0, 0, 1. This goes a little bit. It was 0.01.3, so now it's 0.4. So usually we can do what when we'll finish. So we'll place little tags with and then we'll check later. So if they are doing better, this is 0.07, which is okay also. Oh, this is very small part of the. And this is the other way around. But actually, I'm not sure if the wires are attached properly here. So
maybe the wires were the other way around.
yeah, no.
Used orange for green.
Yeah, it's a bit messy here. I don't understand. Yeah, that's the other way around actually. Yes. So this actually needs to be sealed. Ah, maybe we can leave it like that, so it's not a big thing. So yeah. This is not properly made, so it's confusing. So here actually the red wire is minus and the green is plus, but it's doing very well. 0.12.
Okay. We have enough place.
Okay, so we have 4 cells and all 4 are working. 5. And then there's one more coming. Ah, nice.
Yeah.
Oh, there was smaller here. Take this one. It's hard to operate, no?
No.
Fine?
All right.
So you managed to find the
Yep, I think so.
stone or whatever was there? Yeah. So now it's good.
All right. I think it's closed.
Yeah, yeah.
You want to check?
No, it should be okay. So you have a bridge there, yeah? And now you can attach like just this one on the other side and put it
I
with...
missed this point. So just water here?
Yes.
Okay.
But first you have to attach it because there's a hole, it will go out.
It's open. No? It's open.
Yeah, this part doesn't have to be anaerobic, so it's just oxygen's there. Actually, oxygen is needed there, so.
Okay.
The other part has to be sealed, but you don't have to seal it. That's fine.
No?
Just leave it. Just a mud part.
Okay.
So you can test if you want to test. Here, red is going to the clear water part, so that's a plus, and the mud is minus.
Wow.
No, almost the same, yeah. It's quite okay.
So how many batteries did you need to?
You need an electrode.
Wow.
Ah, wait a second. That doesn't have a...
The
5.
Yes.
Yeah.
Double break.
That's a very small clock. So the clocks are also Raitis. So some.
What's the voltage?
0.0.
For the clock, the original was I think 1.5 volts. But that's only one parameter because you have also amperage, so which is actually the strength of the current. So, and because of that, so you can have like, you need this chain of cells. The voltage might be even like up to 3 volts, but the amperage very low. So each cell is like milliamps. And so how much volts do you have?
0.26.
Oh.
Now let's check the amperes.
So we can have a competition. So yours is now, I think, the strongest one.
Measure mine
This is addiction. So then you'll come after, have a coffee, so you'll come back. So does it go up or just drop? So, and then we can go to the pond, which I'm very keen to try. And here, it goes up or it goes down?
Goes up.
Down.
Shouldn't have measured again.
We can have you go in and zoom on your phone.
I know. Steady.
Can I try? Sure.
Yeah, my phone too, yeah. Any phone.
The red report.
I need to prepare it.
Completely.
Yeah.
So, is it okay?
Okay, let me try to the bottom. Let me try to the bottom.
So it's working?
Yes.
Cool.
19. Ooh. 19.
Yeah, it's a weird addiction. Sitting and measuring.
This means that if you touch it like this, you get electrocuted.
Yeah, you touch it with your tongue. So.
18, 19, 19.
You don't feel it with the.
But can you actually?
You won't feel. You won't feel much because I said it's there.
Kill the bacteria?
19.
I wanted to.
The actually the amperage is what gives you the shock.
What can you do with 19?
Nothing much yet. No, no. So that's what I'm saying. So actually the electronics have to go down in electricity consumption. So then we can use this kind of technology for powering something.
So this one works for what exactly?
At the moment, for nothing. If we put them in a chain, so maybe we are happy we can power one electronic clock.
But it's not stable the way it's measuring, is it?
LED light. 21.
Yeah, but goes up and down.
Because the current is fluctuating.
121.
Okay.
Yeah.
Okay. It's going
Okay,
up
then.
somehow, maybe the heat.
No, eventually it stabilizes, and then it will be stable for a while, and then it will drop actually. So after a while.
Oh, sorry, for and that is all.
So here I have mixed electrode, I would say. So there's a. This will actually be on the top of the water, but this is this folded thing which I told you about. And what we have here, this is a carbon cloth, but it's not conductive. It's just a regular carbon cloth, and that's why I have this stainless steel thing around it. But now I'm trying to make it float. So I will use this thing to kind of keep it on the top of the water. Ah, I still need to attach. One more wire. Let's see. Should be okay. To do it, but
Iron mesh? This?
yeah, it's just stainless steel.
Nickels. You can measure the resistance of the skin. The resistance. I measure 13,000 kilo ohms.
Wow, okay, let's see. What does it measure?
Well, resistance of conductivity in the skin.
Oh, interesting. Yours is higher.
I need to drink more water.
Need to eat more salt.
Where do you put it? The test funded by Scientology shows that you something with an arrow that changes.
Strong believer.
What does it measure? So the arrow just like goes back and forth and then you just interpreted it. Yeah, Scientology. Do you think having just
You can trick people with these things, so yeah. If you didn't learn physics in the school, so you can do any kinds of tricks saying, so whatever those numbers mean. Okay, so we have a top part. Hopefully it will hold it.
It's camera.
This they have too now, but sometimes they have a stand with multiple people. I guess they have to machine that as well.
Is one in the way?
I live next to Spain. The nearsight is huge. For the first time.
Yeah.
Okay, shall we go to the pond? Or, oh, wait a second, I will just take off the
I've never seen one before, actually.
isolation.
It's like a Tamagotchi thing, no? It's,
Imagine here you don't consume electricity because there is not enough, but you care about it.
That's actually living organisms there.
So basically, the more voltage you have, the more bacteria you pass.
And also they're more active.
Yeah.
So if they are not active, and more right kind of bacteria also, there could be those which are not doing anything.
lazy bacteria.
Yeah. Well, so let's go.
Exactly.
Let's go to the pond.
That's why chemical probably.
So take a voltmeter, and we'll see it right away, so if that will work or not. Redz, kur mans margrietiņu dārziņš.